Good afternoon, students. I I'm seeing only 6 of you here.
Night, sir.
How you doing, Papa?
Good afternoon, sir.
Good night, sir.
Hello.
Uh, there was a lot of rain yesterday, and I just got back the lights.
Yeah, I was in a meeting today, and was about to speak, and I recognized my computer shut down, so I had to grab for the phone. Whenever having these meetings, I have to have at least 2 devices up because I had a power cut myself. You know, to be honest with you, I think the rain
Did
has a lot to do with.
he go on and off?
To be honest with you, I'm not sure because I had just abandoned the computer at the time and just went and used my phone. So I was using my data. But what I can tell you is that since we've been getting rains, the internet has been acting up. I kept in class and it keeps bouncing, but guess what? Me glad for the rain, so till that me never problem with me want get bounce. Me log on in the amount of time for log on. As the rain is it's very well welcomed. Very well welcomed. Outside of the internet issue though, are we okay otherwise?
Yes, sir.
Studying?
Yes, sir.
Yes, sir.
Very nice, very nice. Don't let it pile up on you, please. Don't let it pile up. Today I was in an academic meeting and I saw the report that Mrs. Campbell would have submitted. And the top students from the School of Computing, the computing students overperformed in terms of the graduation. The valedictorian was computer student. The one who gave a vote of thanks was computer student. The past student, the distinguished past student was a computer student. And, you know, 2 of the 3 of them, I taught calculus to, and, you know, one of them, the valedictorian, hinted at me in his speech at the graduation ceremony about having to do these difficult math courses, but they survived. And when I saw her, when I listened to her presentation, I'm saying to myself, but if them can do it, them are one of my advocates, and I can do the same thing too. Them can do the same thing. Them bright just like them. So I'm very optimistic. Actually looking forward to seeing you guys walking across that stage come next year when you complete your stuff. Just big up on yourself, but remember, you know, there's no way this can happen if it is that you don't do what you need to do. And what you need to do is to do your work. And once you do that, you're good to go. So, hold on, please. Yeah. Mm. Hold on. All right. So we would have done some work on Newton Rampson. We moved into McLaren's expansion, and then now we need to move on. Where did we stop the last time? Hello? Not hearing me?
Loud and clear, sir.
Oh, okay. So answer me now, man. Where we stopped the last time?
I think so. We stopped at McLaren series.
Right. So we did a question.
Yes. Yes.
We did a
Question
Ellen function
instructions.
question, right?
Pardon me,
Yes,
sir?
sir.
No, I'm
Ellen,
asking. We did a Ellen function question last, right?
Yeah, yes,
Yes,
we
sir.
did.
Okay, good. Just wanted to make sure.
That's not done. Ellen?
That's not.
Yes, we did Ellen.
That's
Week before.
Ellen.
The first class
Yes.
and the second class.
We did a logarithm function.
When we did the logarithm, was it Tuesday? What we did on Wednesday?
We did an Ellen
Ellen,
function.
sir.
Ellen
Right, the
function.
Ellen function. Right, yeah. I'm correct. We did the Ellen function on Friday, on Wednesday. All right. Okay. So we need to move on. We need to move on. And we need to move into some integration now because we would have now covered differentiation, applications to differentiation. We need to move on to integration.
So this is the final topic for this unit.
Say it again?
This will be the final topic for this unit. And then we'll be moving on to the next unit.
No. Moving on to the other unit now. No. We're doing it. No, I'm just trying to find something here. Hold on. No, we're moving on. I'm just trying to find. I'm just trying to find something. Just be around with me. Oh, can I tell you now? Story time. On Wednesday, remember I was having a class on Wednesday and the devices just kept going back. Was it Wednesday or Thursday? Wednesday. And the device was, yeah. And can I tell you that the computer crashed? Right? And well, let me not say crashed. Yeah, it did crash. Well, yeah. Something is wrong. Is the battery is either not charging, or it is that the plug is not, the charger is not working, but the computer says fully charged. And even when it is plugged in and says fully charged, by the time I turn on the computer and start to move from one document
But you need to replace.
yeah, man, I know. It jumped down to 90%. And by the time it reaches 50%, best believe the computer shutting down. Yes, sir.
The battery not good. But
So I am
cause I had the same problem then, and then the laptop got said the battery need to replace.
okay. So fortunately, I have a student reach out to me and said, "Oh, sir, I'm traveling." I said, "Great. This is the dilemma that I'm facing." I said, "Not a problem." So, but that's not until early next month. However, I was smart enough over Christmas to have gotten a new system. So it's not that I'm left in the cold, because I saw a few signs, and I was a little cautious. But what I am a little worried about is that I have all my documents are on that system, and the software that I use to do those beautiful type up is not on this new system. So I'm now trying to find a document, which is why I have not yet started sharing. So the system comes up, but it comes up and I cannot use it for more than 10 minutes. If I want to retrieve a document, I have to turn it on, make sure that 10 minutes don't pass, and then not shut down the computer. So that's the story of my life. But
Wait, I haven't got the vote yet. Oh God, I hope I get it.
all right.
Yay, I won this
Whew.
flag.
Hold on a minute, please, guys.
Like without a tiebreaker. I want to be a school president because like an exotic pet. A tiger. Is that legal?
Is that you?
Yay! I'm gonna name it Freedom. I'm such a cool president. While using the bathroom in your office, you overhear one of the housekeepers.
Come on, your mic is on.
They can work you without a visa.
Come on, your mic turn on.
Wait, what visa?
All right. So I don't want to let you know what it is that I want to let you know what it is that I'm doing. I don't want you to feel like I've abandoned you. What I did was to email myself some stuff that I actually worked on in preparation for this class. So I'm now trying to Lord, I'm not connected, but I don't have data. So why am I not connected? Hey, what is happening to this stuff? I have data. Turn off the Wi-Fi and use- Computer students, help me out here. I have data on my phone. Why is it then that I am not able to serve? I am using the Wi-Fi and I click off the Wi-Fi, but I'm still not getting on. This don't make sense.
You check your phone, check your phone, see how much data you have left.
No, man, I have enough data.
No, just check it. Just check that time how much you have.
All right, hold on there now.
Good evening. What are you doing, sir?
En español. You understand that?
Como to what subject again?
Spanish, sir.
Many tell me words you're not supposed to tell me, you know. You understand?
What subject in Spanish again? What subject are we doing?
What subject? We're doing mathematics today. What is? You know what? Leave that alone, Chan. Oh, so all right. First of all, nothing is working for me. I don't know. This internet business, let me go to the computer that don't have the software on and see if it will bring it up. NOT. All right. So what I did for you, I prepared a nice little stuff for you on applications to differentiation and of integration, sorry, applications to integration. And I'm hoping that you will find it pretty interesting. That we can move on from there. You know how to integrate. Well, I'm hoping that you remember how to integrate. And before I even move into into any of those stuff, I should go through what I call the trapezoidal rule. Somehow it's just not working out for me. But I'm going to see how best I can share the document. Let me try opening it to see if, oh,
Visual one.
all right, so all right, I'm converting. It says to me, wait a minute. All right, so the application to integration, just like the application to differentiation, we are going to be doing the trapezoidal rule is us integrating a function without doing the actual integration. What it does, it gives us an approximation to the integration. So I can give you a
someone that
definite.
use a calculator for.
Huh?
This sound like someone that use a calculator for.
Yes, you have to use a calculator because I mean you'll have to go and do a subsidiary calculation now. So when you use your calculators to evaluate the stuff. And having evaluated the stuff, you're going to what you get as your answer should be close to the actual integration of the question. And sometimes what the exam may ask you to do is to do the actual integration and to calculate the error in using the approximation. So what we're doing is going to be using a trapezoidal rule, where it is that we're using different trapezoids to do our calculations. Now, while this system converts this file to a PDF so that I can move on, I want you to raise one of your hands, either right or left. Either right or left. Then what I want you to do, I want you to spread your fingers apart from each other. And I want you to count and tell me how many fingers you have.
Wait, you want us to hold our fingers together and then pull them apart?
No, Crosswell. I want you to have your fingers. I want you to any hand, either your left or your right. And I want you to just spread apart your fingers. And I'm asking you, how many fingers are you counting? And there's a reason I'm asking that.
4.
You're counting 4. Your thumb is a finger incidentally too, here. It's just that it has a special name and it's called a thumb. So including your thumb, your index, your middle, your ring, and your pinky winky. How many fingers are you all seeing there?
5.
You're seeing 5. All right. There's a reason I'm asking. Yes, I know all of us should have 5, but some persons may have only 4. For some accident or another, or some people may have that extra finger at the end of the pinky. All right. And there's a reason I'm asking. So you're all seeing 5 fingers. All right. Am I to assume yes? No?
Yes, sir.
All right, great. Now, so I want you to space out those 5 fingers. And I want you to tell me how many U's can you count, or V's for that matter, can you count on that one hand?
4, sir.
4, sir.
You can count 4, and I can count 4
many
also.
what?
So I know that. Say it again.
How many what?
V's or U's, you can count from it.
V's from your fingers.
On the fingers. How many V's can you count?
3.
Okay, so the other one is what? Other one is a what? A C? No, talk to me, no man. I'm not trying to be facetious, you know. I'm really actually trying to get you to see what is happening. There's a story behind this. Other teachers don't teach it like that, but I do this because I want you to understand what is happening. Some people said 4. Those who are seeing 4 fingers, you want to turn the video on and show, sorry, 4 V's. You want to show you them the class where you got the 4 V's from? Because I'm getting 4 V's also. Anybody, somebody? No? Yeah? By the way, are you guys hearing me? Am I disconnected?
Right here, sir.
I'm hearing you, sir, but I didn't get what you were saying.
Okay, no, I'm just asking. If you open your fingers, how many fingers are you seeing? And of course, we are assuming that your thumb is a finger, and it is. So you're seeing 5 fingers on your hand: a thumb, an index, a middle, a ring, and a pinky. All agreed right there?
Yes, sir.
Yes, sir.
All right, good. Now, I'm asking the question: how many V's can you see from those 5 fingers? How many V's can you identify using those 5 fingers?
Sir, 4, sir.
4, Mikey. Mikey, it's been like the whole of last week. I don't see you.
Sir?
And you can't tell me say they did the whole of last week.
Sir, the
Of
one
course,
with
sir.
the
Sir, it's just one class I miss.
finger on the next
I'm
one.
at all of your classes, sir.
You were here the whole of last week, Mikey?
All of your classes except one.
Mikey, you need to go and pray. Anyhow, Lotto, I hear you saying something. Where you say, Lotto?
The one beside the big finger on the next one don't look like no V.
Wait, look like one C?
Yes, sir. More like C.
How big and them big? You need too much flour. All right. Do me a favor. Squint it up a little bit and you'll see the V. All right. But the point is, you can count either a V or a C, don't? Are you seeing that?
Yes, sir.
All right. Help Crosswell now to decide that you're supposed to have 4 V's. So please, Lotto, because I don't think him saying only get 3. And him the tell me same have 5 fingers.
One between
3 V and 1 U.
You have 3 V and 1 C? All right then.
U.
And one what?
Umbrella. U.
One umbrella?
U.
No, sit wrong in your hand then. All right. So each of those V's are bounded by what we call the legs of a trapezoid. So each finger is representing a trapezoid, document not opening, but each finger is representing a trapezoid. And between fingers, each finger is representing one side of a trapezoid, and between 2 fingers is a trapezoid. So you can't have a trapezoid if it is not bounded by 2 fingers. So your pinky and your ring finger would be, between your pinky and ring finger, that V there is a trapezoid. The ring finger and the middle finger makes it the second trapezoid. The middle finger to your index finger would be the third trapezoid. And somehow, the index finger and your thumb will form the 4th trapezoid. So can you agree with me that in between your fingers is a trapezoid?
Oh.
Yes, sir.
And can you also agree with me that considering that all is well with you, you'd have 4 trapezoids? Agreed?
Yes, sir.
For open spaces.
4 open spaces, all right. And of course, because some need more flour than the others, you can have a bigger trapezoid, right? But don't worry about it. In real life, the trapezoids can be very big and can be very small. But before I move into the stuff, what I want you to get from me from now is the understanding of trapezoids versus ordinals. Say ordinals for me, please.
Ordinals.
Ordinals. All right. Open back out your finger them and count how many trapezoids we have again. Count how many trapezoids we have.
4.
4. How many fingers?
5.
Very good. So in real life, when you put up your, and when you go into exams, I want you to do the very same thing so that you don't get mixed up with it. So when you open out your hand, you recognize you have 4 trapezoids and each finger is going to represent an ordinal. So you have 4 trapezoids, but 5 ordinals. We have one more term in your ordinals when compared to your trapezoids. All right. So, by the way, do you understand that you have 5 ordinals, 5 fingers?
Yes, sir.
But you have only 4 trapezoids, 4 spaces between fingers. Agreed?
Yes,
Agreed,
sir.
sir.
So the number of ordinals is 1 more than the number of trapezoids. Do you agree with that?
Yes, sir.
All right, do me a favor. I want you to say that 5 times to yourself and find a way of trying to remember that. Real talk. I don't want you to just say true foolishness or talk, but I really want you to say it 5 times to yourself because I was waiting for the computer to come up and it is not up. By the way, are you seeing my screen?
Yes, sir.
All right, good. And I want you to, sorry, these writing here looks out of sync, and it's just because I don't have the software loaded to this computer as yet. So that's why it's going to look like that. So don't worry about it. I will sort it out sometime soon. All right. So just remember now, if in doubt, in the exam, multiple choice or otherwise, all up your hand. Spread out your fingers. Look at it. You have 4 trapezoids. The trapezoids are those that are the spaces between your fingers. And your ordinals will be the fingers themselves. So you end up having 1 more ordinal than the trapezoids. Why is this important, sir? I may give you a question to say, approximate the integral of this. Approximate the integral of this using 4 trapezoids. Or I may say to you, approximate the integral of this using 5 ordinals. So somebody may read the question and say, no man, the question says 4 trapezoids. And then somebody said, no, it's a 5 ordinals, but it means the same. It means the same because the number of trapezoids would be 1 less than the number of ordinals. So if I say 4 trapezoids in 1 question, using 1 function, using the same function, but me just saying to you now, using 5 ordinals, it's the same thing that I'm asking you about. Because 1, if I give you the ordinals, you will have to now go and convert in order to use the number of trapezoids in order to calculate, do complete your calculation. All right, so it's very important. So let me just go ahead now with what it is that I'm trying to explain to you here. The trapezoidal rule. I'm going to ask you for your undivided because it's going to be very critical for us to get some understanding as to what is happening. So it says this technique is a much more accurate way to approximate area beneath a curve. Now in calculus 1, we went through the whole gamut of calculating the area under the curve. And we spoke about when we would have calculated the area under the curve, we need to talk about our units squared because we're calculating area. Now to construct the trapezoids, you're going to mark the height of the function at the beginning and end of the width of the interval. And then you're going to connect those 2 points. However, this method is going to ask of you to memorize a formula as per the other methods. Yes, you cannot get rid of it. And no, they will not give you a formula sheet in exam. Just as how I've shown you how to memorize the other formulas, this formula is pretty easy to memorize. There is something special about this one. I'm going to repeat what I said earlier, because if you fully understand what it is that I just did, the exercise I just did, it makes the formulation work so much better. All right. So you have 5 fingers. Each finger is an ordinal. The spaces between your fingers would be called trapezoids. I cannot have a trapezoid that is not bounded by 2 fingers. So to the left of the pinky, if you're using the left hand, to the left of the pinky, I cannot have a trapezoid because it's not bounded by another finger, which is why I asked if anybody have one of those extra little fingers, right? Because if you have an extra little finger, this exercise is not for you. Or if you lost one of the fingers, I couldn't use that to demonstrate it, which is why I was asking how many fingers you're seeing. It wasn't a rhetorical question, really. So if you cannot have a trapezoid that is bounded to the left of your pinky, if you're looking at your left hand, or to the right of your pinky if you're using the right hand, because a trapezoid must be bounded by 2 fingers. Remember that. A trapezoid must be bounded by 2 fingers. All right, so let's go. So the definition, it says, let f be continuous on an upper limit and a lower limit, and the trapezoidal rule for approximating will be the integral of a function, with respect to x using an upper and lower bounds. Remember, you're calculating the area of, well, you're approximating, not calculating, but you're approximating the area beneath a curve. So to approximate an area beneath a curve, remember, you can't have an indefinite integral. You must be given something that is definite. Because if you're asked to approximate the area under a curve, you must be given specific information about this curve, upper and lower limits, so it is that you can go ahead and calculate the area bounded by that function. All right. So what is seen in square brackets, what you're seeing in square brackets would be my upper limit and my lower limit. If you look at my function to the right of that, you'll see my b be my upper limit, my a be my lower limit, and the function f of x, b of x. The function is in x, and I'm integrating that function with respect to x. Do you understand all of that, class? Okay.
No.
No, sir.
Sorry.
No, sir.
All right. Let us go back to calculus 1, because I have not yet started anything on calculus 2. So let us go back to calculus 1. Remember, what is the difference between a definite integral and an indefinite integral? Let us start there. A definite integral has?
Definite integral. It has upper and lower boundary.
The indefinite integral has?
Definite integral. What does that again?
Say no upper and no lower boundaries.
No upper and no lower boundary.
Very good, Crosswell. So a definite integral has an upper limit and a lower limit. An indefinite integral does not have an upper limit, neither does it have a lower limit. When I'm integrating a definite integral, I am going to get my answer in units squared. When I integrate an indefinite integral, I must end with what? Good dear. What
Wait,
must I end with it for indefinite integral?
Indefinite integral. Christ, what was it again?
Unit.
No, as far as I remember it, when you wrote those things, you always would say, you would always write a formula plus C or something like that. I can't remember.
Thank you very much, Crosswell. Plus C. And C is what is known as what?
Constant, yeah, the constant.
Constant of?
The integral.
Constant of integration. I don't know, say, when you come to calculus 2 and just dash with everything we learned in calculus 1 through the door. Right? So the difference, the main difference between an indefinite integral and an indefinite integral, you get a specific answer for your definite integral, but your indefinite integral, you're going to end with your constant of integration. Fair enough? Are you remembering that? Is that anything that I taught you in calculus 1?
No.
No?
Yes, sir.
Okay, thanks, Courage. Does anybody else remember? Only need to tell me, so I can go and amend those grades that went in some weeks ago, because it means that I have to put it back into calculus 1. Can you speak to me, guys, please? I need to know before I move on.
I'm looking in my book.
You're looking in your book. All right, let me know when you're finished, because I'm not joking. I'm actually very serious. I want to know that you remember what is happening right here.
Let's see. Oh, so that's why I mentioned integral.
Yeah.
So based on this, the technique is to make a more accurate way to approximate that beneath a curve to construct the trapezoid or at the height of the function at the beginning and the end of the width.
No, that's not what I want you to look at in a crosswell. I will explain that. What I want you to remember is when you're integrating a function, you must have your upper limit and your lower limit if it is that you're speaking specifically about a definite integral. So my definite integral is when you look like this. B, atop the integral sign A, B be my upper limit, A be my lower limit, and the function f of x. The function must be in x for me to integrate with respect to x. So my d of x says that I'm integrating the function with respect to x.
And then you'd subtract b, a from b to get your trapezoid integral.
Yeah, but no, man, you're moving ahead of me, man. I don't reach there so yet, Crosswell. Clearly you're looking at something, but I don't reach there yet, man. Hold on. I want persons first.
No, I'm just trying to remember. No, I'm remembering how you'd go about doing the integral thing. First, you'd find the integral of b. Yeah, first you'd find the integral of b and then you find the integral of a. That would be that first.
Hey boy. Remember, you're going to integrate the function. All right, hold on. I really don't believe this is happening. Like, seriously? When I say God, no. I really cannot assume that you guys. All right, look at this example number 2. I've given it a function, 4x cubed minus 5x squared plus 2x minus 1. Is that a function in x? Yes or no?
Yes.
Yes, sir.
It is a function in x. I'm integrating that function with respect to what?
You're integrating it in respect to both 3 and 2.
No.
X, sir. X.
I'm integrating it with respect to x. How do I know that I'm integrating with respect to x? Because of that dx that is there. The dx is telling me that I'm integrating with respect to x. If I had dy, it says that I would be integrating with respect to y.
Right.
If I had dr, it means that I'll be integrating with respect to r. All right? Now, when I have the function, look at this example that I have projected here. When I'm integrating, I'm adding 1 to the power and divide by the new power. So 4x cubed is going to become 4x to the 4th power divided by 4. Yes or no?
Yes, sir. I see that in my book.
All right. Because this is a question that we did in calculus 1. Minus 5x squared. I'm integrating 5x squared. It's going to become 5x cubed over 3. Agreed?
Yes, sir.
When I integrate 2x, remember the x is raised to the 1st power. Integrating 2x, it becomes 2x squared over 2
minus
because
1x.
we're adding 1 to the power and dividing by the new power. True or false?
True.
Okay. And when I integrate a constant, what do I get? Say the variable.
And 0.
No.
The variable is what was
itself.
said.
When you differentiate the constant, you get 0, Lotto. But when you integrate the constant, you get the variable. So when I integrate 1 with respect to x, I'm going to get x. Remember, we don't say the integral of 1 dx. We just say the integral dx. Remember?
Yes, sir.
No, sir, I don't remember nothing at all. Oh, my Lord and Father. This is not happening. Let us go back to the rules of integration. Can you read rule 2 for me, please?
The integral of 1, written simply as dx, not 1 dx, is integral dx equals x plus c.
Did I give you this last semester?
Yes, sir.
Yes, sir, we have it.
Yes, sir.
No, I didn't. I didn't.
Okay,
You're
no,
seeing this for the
you
first
did.
time. You're seeing this for the first time.
No, you did show it to us.
Not only show, you guys should have a soft copy of this. I prepared
I
this
have
for
a
you.
soft
last
copy,
semester.
sir. I saw it over the weekend.
Yes, man. When I can't remember, no. You said whenever you're doing a course, a new course, and it has a prerequisite, it means that the prerequisite course has to be fresh in your headspace. It's not a standalone course where you do that something there and just leave it alone. Many of the things that I speak about in Calculus 2 are going to be referenced from Calculus 1. So I don't have the time to reteach it. I apologize. I'm going to assume that you know, which is why the prerequisite for the course is Calculus 1. And you can't do Calculus 2 before you do Calculus 1. So do you understand why we don't say 1 dx, we just say the integral of x? The integral dx rather?
You know, I'm not liking the fact that I'm the only one speaking, you know.
Sir,
No,
you
I don't.
hearing me?
I'm not hearing you at all. And you
Well,
can't
why
see that
you
you're
want
speaking.
speaking? Is you one in here? About you want?
Sir.
When anybody
I'm
else
not-
speak.
I'm not hearing you, Joe. Were you speaking, Joe?
Yes, sir. I just got back connections because I just came off those and I'm not seeing what you're sharing.
Am I sharing? Are you seeing?
Yes, sir, we're seeing. Probably she have to log out and log back in.
Log out and try log back in for me, please, Joe.
Okay.
All right. So there are 9 of us here now. Mr. Francis, good afternoon, sir. How are you?
Sir?
Are you seeing it now, Joe?
No.
All right, hold on. Andre, can you unmute for me, please?
Yes, I was waiting on you to finish what
You
you
were
were
waiting
doing.
on me to what?
Finish what you were doing. You stopped sharing and you were resharing. So
Oh,
that's
okay, yeah. Why don't you speak to me in class?
well, I speak sometimes, sir, but not as often as everyone else.
Yeah. So how you think in this online realm, I will know that you are understanding?
If I'm not understanding, then I normally would say something, sir.
Oh, so
Go ahead.
okay. That means if I'm not hearing, so if I were to follow your argument, then when I ask a question and I ask if you're understanding and I don't get a response, it means that I can move on.
Yes, sir. Yes, because I'm
Okay, so that's what
getting.
it means.
But I'll notify you, sir. Going forward, so that way you know I'm following.
Okay, thank you, sir.
You're welcome. But this integral thing, it's not fresh at all. So,
But you
yes,
don't say nothing. That's the point. It's not fresh, but you're not. You see, you're
But-
contradicting yourself, you know.
But you're
Come on,
just going over it again, sir. So it's kind
Come
of
on, come on.
refreshing a little bit, but it's
Yeah,
not that fresh.
But the point I'm making, Sir Francis, is based on the non-response from the class members, why I had to go back into Calculus 1. So if you had said to me, sir, remember it's long time I do Calculus 1, I don't remember, you know. You don't say it. Bijan, I don't understand. Or you come at the I class and you not talk today, you know. What happened to you? You guys have a mid-semester later?
It's supposed to be during the next the week after.
No. Do you have a mid-semester from 7 to 9 tonight?
No,
Seven.
sir. No,
So
sir. Not that I know.
what's the problem? I mean, if you don't want to have class tonight, then it's fine by me. It's really
Sir,
fine by
just
me. I
lost
can
connection.
say it again, Mom.
Good evening. I'm just lost a little, so I'm just
You
going
just
to
lost a
try
little.
to-
All right.
Yes.
I thank you for your
and
honesty.
reading the document and reading the document.
Yeah, man. I thank you for your honesty. What about the others though?
So I'm currently
Jeremy
lost
lost
at the
a lot.
moment. But I
You're
found
lost a lot. Okay.
A lot. Yeah,
Yeah,
a
I-
little meal. I mean, me lost a lot.
You lost a lot.
But I'm
Okay.
listening in, so hopefully me catch
All
on.
right. You need to change the name though from Missy though, yeah, mommy? For
Jeremy, no, it automatically keeps going back to that because I log in using the
yeah, never mind. Just click on it and just rename for yourself for me, please. All right. Mikey, what say you?
Sir, I'm looking through the document that I have. A refresher.
Oh, so you don't remember? So you're saying that you don't remember either, right?
Not fully, sir, but may I go through the document?
Okay. Tony Ann, what say you, hon?
Yeah, okay, somewhat.
Okay, somewhat. Courage, what you say?
So,
You understanding?
yeah, I remember the rule.
But you should.
So,
You should. All right. I'm saying you should. All right, so I'll just go and just change your grade and say, no, I don't think she deserves this grade at all. All right. All right. Let's go again. Wow.
sir. See me
All
here.
right.
I tell some always sign in with the SSO, but I don't know why it always go.
Oh, you're using an online version of Zoom.
No. I'm using the software.
Okay. All right. Let me try this again. Because what I just revised with you a while ago has absolutely nothing to do with
Trapezoid.
with the revision, no, with the revision of what it is that I just did. What I want you to do for me is I just want you to focus on something here. 1 minute. I just want you to focus on something here. I'll come back to the revision sometime later. You know what? Yeah, I'll come back to the revision sometime later. What I was saying to you though, Crosswell, let me just clear that up first before I move back to what it is that I'm doing. You notice when I'm doing this indefinite integral right here, I have no upper limit or no lower limit, so I just integrate the function,
Yes.
and I mostly my plus c. When I'm integrating a definite integral, on the other hand, the definite integral will have my upper lower limits, and then I'm going to be using the upper and lower limits to subtract the lower from the upper, as in this case, in order to represent the area under the curve, as I've done in this case. All right? So this is what you're going to revise for me for next class. But just allow me to go through the trapezoidal. I was only trying to make reference to it. Allow me to go back to the trapezoidal, and then we can pick up the shortfall from there. So all of what you're seeing right here, the upper limit b, the lower limit a, f of x, the function in x, I'm going to differentiate with respect to x. The dx is saying that I'm integrating with respect to x, not differentiate, but I'm integrating with respect to x. All right? So that's what the function is going to look like. But let us not talk about the function just yet, because the function let us talk about the function. So it says the integral of my upper limit and lower limit, because I'm speaking of a definite integral, of my function f of x with respect to x. Now that sign that looks like V of X, it's really the change in value of X. That sign means the change in value of X, in the value of X. So what I'll be doing is subtracting my upper limit from my lower limit. I'll be subtracting my upper limit from my lower limit. So if you look at it carefully, you'll see the definition of V of X, which would be B minus A over N, where N is a number of trapezoids.
B is the upper limit and A is the lower limit.
Where N is a number of trapezoids.
That's what I said,
Where,
sir.
huh?
No, Sin, that's what I said.
Yeah, but I didn't want you to go there just yet. But yes, N is a number of trapezoids, right? Now, let us go back to our fingers again. Remember, your fingers are representing your ordinals. Your fingers are representing your ordinals. And between fingers is representing the trapezoids. I want you to recognize, the formula that is in blue, the section of the formula that is in blue, that is the start of the function and the end of the function. I want you to recognize the section of the formula that is in blue, that is at the start of the function and at the end of the function. Now, you remember me saying to you that a trapezoid is defined between fingers. So if you're using your left hand, there is no trapezoid to the left of your pinky winky because you don't have another finger out there. All right? So that's why I have my X naught and my X to the N in blue. Do you recognize that every other term has a 2 being multiplied by it? Look at the function in pink, that every other term has a 2 being multiplied by it. Yes or no?
Yes, sir.
Yes, sir.
All right. That 2 is representing both sides of the trapezoid. So let us look at the trapezoid that is formed between your pinky winky and your ring finger. The trapezoid that is being formed by your pinky winky and your ring finger is going to be, that 2 is representing the 2 sides of that trapezoid. The trapezoid that is formed between your ring finger and your middle finger is going to be multiplied by 2. That 2 is representing both sides of the trapezoid. When you look at the blue, you recognize that it's going to be multiplied by 1 because it's just one trapezoid that it is resting against. It's not resting against another trapezoid. So it is very important, very, very important, that when you're doing your trapezoidal rule, you will remember that your first point, which would be your upper limit, will not be able to be multiplied by 2 because it's not touching 2 sides of a trapezoid. It's touching only 1. So would be the last side. Only the trapezoids that are in between will be affected by both trapezoids. All right.
Sir?
Go again. Go, Courage.
Sir, can you please reshare your screen? I'm not seeing it.
All right.
Oh, don't worry. I'm seeing it now.
All right. So it says my Vx is going to be used to find the width of the trapezoid. My Vx is going to be used to find the width of the trapezoid. And I'm going to subtract the upper limit from the lower limit, and I'm going to divide by the number of trapezoids. N represents the trapezoid, of course, B represents my upper limit, and A represents my lower limit. All right? Now, the area of any trapezoid is going to be half the sum of the parallel sides times the perpendicular height. So this now is taking you back into C-set mathematics. To calculate the area of a trapezium is going to be half the sum of the parallel sides times the perpendicular height, which technically is going to be the base of the parallel sides. All right? Now, the trapezoidal rule is going to overestimate a curve that is concave, and it's going to underestimate a function that are concave.
You mean convex?
It's same one. Yeah. That's it, Crosswell. So I want you to look at this diagram here now. Just focus on the diagram. Just focus on that diagram 1 minute. Focus on that diagram 1 minute.
Overestimate a curve that is concave up and underestimate a function that is concave down.
No, yeah, okay, yeah, that's fine. Yeah, but just look at that function, that curve for just a while longer, and let me explain what is happening. All right. Now, how many trapezoids are you seeing between limits right there?
Three, sir.
Very good. You're seeing 3 trapezoids. How many ordinals are you seeing?
4.
4, sir.
Very good. Excellent. You're seeing 4. So 3 trapezoids, 4 ordinals. Remember, the number of ordinals to trapezoid is going to be 1 more. 1 more ordinal than trapezoid. 1 more ordinal than trapezoid. So if you look at my function, my curvy function, f of x, I am going to be creating trapezoids that are equidistant from each other, meaning that they're equal distant. All right? So the distance between A and x1 is the same distance between x1 and x2, the same distance between x2 and B, my upper limit. So these trapezoids are not just random spacing. They are going to be equidistant from each other. Equal distant from each other. All right? Now, let us look closely at the trapezoid. I don't have a pointer using this, sharing this document. So I want you to look at what is happening. Can you see my cursor?
No, sir.
Not yet, sir.
All right. No, so I don't think you'll, let me see something. No, I'm not able to. No, I'm not able to. No, I'm not able to annotate right here. But just work with me. Let us look at the first trapezoid. You recognize that the trapezoid is, sorry, the first trapezoid. Do you recognize that the trapezoid is, there's a space between the curve and the trapezoid?
Yes, sir.
What that means, Crosswell?
Wait, the mic was on?
Yes, sir. What means?
I was taking your semi into consideration.
So
You said
answer
that
my question.
Go
Answer my question.
ahead with that point, sir, that you just made. There's a space between what?
There's a space between the curve and the trapezoid. Do you see that white space between the curve and the trapezoid?
Oh,
Yes, at the
yes.
top,
Yes,
yes.
I see it.
Right. So can everybody else see it?
Yes, sir.
Yes, sir.
All right. Thank you very much. Thanks, Tajiri. Thanks, Mikey. And the rest of them not in class, but enough
Sir, you're
talking
not
to
hearing me.
Joe, you're always talking and none of us hearing you. Anybody hearing
Sir.
Joe?
Sir, no. So you hear me now?
I'm hearing you, ma'am. I'm hearing you now.
Okay.
All right, thanks. So is this an underestimation or would be an overestimation?
Over.
It should be.
Sir, probably an overestimation and the one.
No.
Remember, I'm calculating the area under the curve. So I want the total area under this curve. When I look at the first trapezoid, am I calculating the area, the total area under the curve? Or there's a portion of the under the curve, the area under the curve that I'm not calculating?
They're not calculated there under the curve.
What area am I not calculating?
The unshaded one.
Very good. So the area that is unshaded, I am not calculating at all because my trapezoid does not go up to that point. Can you see that?
Yes, sir.
The white space wouldn't be.
The white space is a part of the area that I will not take into consideration. So this trapezoid will be an underestimation rather than an overestimation. Agree?
Agree now, sir.
Okay, good. Let us look at the third trapezoid. Would that be an underestimation or an overestimation?
Sir, over.
Yeah.
What is a Lotto? I hear you, Joe.
Sir,
What is a
over.
Lotto?
I said
Yeah,
over.
Okay, over. Everybody agrees that it's over?
Yes, sir.
Yes, sir.
Okay, good. So that would be an overestimation. Good. I'm happy you see that. Tell me now, would it be under or over for the second trapezoid?
Sir, a little bit over.
What's the rest of
above,
it?
sir.
Sir, a little bit
Above.
under. Sir, may I say a little like white piece?
It would still be above.
I'm sorry.
A little bit above, sir. It would still be a little bit above.
I agree with you, Crosswell. It would be a small overage.
Okay, I'm not seeing that.
Come on, look at it again. It's maybe because
look at the curve. Look at the curve and use basically.
I'm seeing it probably way down to the end, but not from the start.
Yeah, so the overestimation for the third trapezoid is going to be greater than the second one. Talk truth.
Yes, sir, because it's
more defined.
Yes, and it's closer to the actual trapezoid than the previous one.
I would agree with you. All right. So this is it. So the approximate, and that's why it's called an approximation. So if you have an underestimation, if you have too many underestimation, the area of your trapezoid using the trapezoidal rule is going to be far less than what the actual calculation is going to be. But what is perceived to be true is that if you have a mixture of underestimation and overestimation, then the underestimation will be compensated by the overestimation. Does that make sense?
Sure, explain again, please.
Okay.
Meaning it basically balance out, sir.
That's exactly what it means. So the underestimation will compensate the overestimation when it is believed that the underestimation will compensate for the overestimation when we use the trapezoidal rule, because some of the trapezoids will be underestimated where some of the other trapezoids will be overestimated. So it is expected that my overestimation will be compensated by the underestimation and vice versa. So it means that when I use my trapezoids, I should be able to calculate very close to the actual calculation using a trapezoidal approximation. Make sense?
Mhm.
Yes, sir.
All right, let me ask you a question. Hmm. I'm trying to find, all right. This one is maybe far-fetched. But if I'm trying to melt some chocolate and I have the whole bar of chocolate, whole bar of chocolate, and put it in a
Microwave.
pot. No, in a pot. Or even a microwave. There, yeah, in a microwave. But this time around, I would have grated the chocolate and put in the microwave. So both of them are being subjected to the same condition. So one, I would have grated chocolate, and the other one, I would have whole chocolate bars. And I'm melting. Which one do you think will be melted faster?
The grated chocolate.
Why?
It's
It's
in a more
shredded.
it's in a more
Smaller feet, yes.
in a more condensed form, and it's exposed directly to the heat as well. So it would take up less time than an entire block of chocolate that is put on the same condition.
Everybody agrees with Lotto and Crosswell?
Yes, sir.
Yes, sir.
Okay.
Agreed, sir.
Oh, all right, good. I forget I was told that when I don't hear any response, it means that you agree. Okay, yeah. So that's very good, because what happens, an increased surface area increases the rate of a reaction. It sounds very chemistry, but I just wanted to use a layman term so it is that you can understand what is happening. An increased surface area increases would increase the reaction. So you're right. You're very correct. Now, the mere fact that I have a greater surface area would suggest that I'll have more of the chocolate being exposed. So therefore, the one that is going to be shredded or grated is expected to be melting faster. And you are 100% correct. What's the point, sir? How does that relate to the mathematics we're doing now? Thank you for asking. When I increase the number of trapezoids in my calculation, my approximation gets closer to the actual answer. Does that make sense?
Sir, repeat for me, please.
When I increase the number of trapezoids, I am increasing the possibility of me getting the actual answer when I do the approximation. I am getting closer to my answer.
Oh,
Sir, yes.
that makes more sense.
Everybody agrees with that?
Yes, sir.
Yes, sir.
Sir, but wouldn't it take longer?
It will take, yeah, because we have many more of these calculations to do, but that's not the concern. Your concern is you want to get as close to your answer as possible, don't it?
Wait, accuracy or precision?
No, it's approximately.
No, accuracy, precision, same difference. Remember, what we're doing is an approximation, you know. So the point I'm making is to increase the accuracy of my approximation. The more trapezoids I use, the greater it is that I'll get to the actual answer than if I use less trapezoids. That's the point I'm getting at. Do you agree with that?
Yes, sir.
Yes, sir.
Yeah, man, because if you tell me that if I increase the surface area, if I have more shredded chocolate, it's the same bar of chocolate that I'll buy. Same weight, same condition. The only thing that is changing is that I am going to be shredding one or grating one and use all the contents of the grated chocolate. And I'm subjecting both chocolate conditions to the same temperature in the same microwave, but it is expected that the grated or the shredded chocolate is going to be melting faster because I would have had an increased surface area. I have more surface area in the stuff. So yes, Joe, I'll end up having more calculation, but that's not our concern. Our concern is that we want to increase the accuracy of our approximation, right? Okay. So just bear in mind what it is that I would have said to you. Sometimes they give multiple choice questions surrounding the conversation that we just had. And if you're listening intently, you should be able to answer any question because I'm explaining to you how the method works. It's one of the better approximation, integration approximations that we have. And there are many of these approximations that we have out there, right? The only one that I'll teach you is a trapezoidal, unfortunately, but the only one that you are required to learn. So let us look at an example. Let us look at an example. It says to use a trapezoidal rule to estimate, and again, I'm going to apologize for how the function looks. Really and truly, it's because I don't have the software on the thing. It's really not in line. It's out of line, but you still can see, thankfully. So we're going to be using the trapezoidal rule to estimate the integral of x squared minus 3, upper limit 2, lower limit negative 1. Remember, your upper limit has to be the bigger one, and your lower limit is the smaller of the two values. So let us apply the trapezoidal rule. Remember, n represents the number of trapezoids. So this one is saying that we have 3 trapezoids. And incidentally, this question that I wrote, clearly this drawing wasn't mine. I copied this drawing from the internet and then generated a question to mimic this drawing. So n equals 3 will represent these 3 trapezoids that I have right here. So 1, 2, 3. All right. How many ordinals do I have?
4.
4. I have one more ordinal than I have my trapezoids. If anybody's going to the exam and do anything untoward, I cannot forgive you because I would have given you an example for you to raise your hand. You can't forget this ever. Let's go. So what I'm going to be first doing is to work out my change in my limits. My upper limit minus my lower limit divided by 2. So you have to always do that. Before I do that, actually, I'm going to do this. My Vn is going to be my b minus a divided by n. My v of x is going to be equals to, for all value of x, it's going to be b minus a over n. So I'm going to subtract the lower limit from the upper limit divided by the number of trapezoids. Now, what this does, it gives me the width of the trapezoids. Look at that. So v of x is going to be 2 minus 1. The upper limit is 2, the lower limit is 1. So 2 minus 1, when I'm subtracting 2 negative signs like that, it becomes a positive sign. So 2 minus 1 now becomes 2 plus 1, which is equal to 3. And 3 divided by 3, the number of trapezoids that I have, you see, it says here n is equal to 3. 3 divided by 3 suggests 1. So this one tells me the width of my trapezoid. And this is how we find the width of the trapezoid. Remember, the width of the trapezoid is consistent at all points. They are equidistant. It's equidistant. It is equidistant, right? The width of the trapezoid is equidistant. So I can't have the width of one of the trapezoid to be 1, and then the width of the other trapezoid to be 0.8 or 0.9 or a half. It has to be the same thing. The width of the trapezoid is supposed to be the same thing. Must be equidistant. All right? Now, remember I have 3 trapezoids. N is equal to 3. N represents the number of trapezoids. All right? Now, I need to evaluate my ordinals. Remember, I must start with my lower limit and end with my upper limit. And that's how you end up with 1 extra than the number of trapezoids. So my start point is going to be -1. See to yourself? My ordinals are -1. When I add 1 to -1, what do I get?
1 to -1?
0, sir.
0. So see, 0 is the next one. When I add 1 to 0, what do I get?
1, sir.
1.
Good. So I get 1. When I add 1 to 1, what do I get?
2.
Do you see how it is that I just calculated my ordinals? I must start with the lower limit, adding the width of the trapezoid to the lower limit to give me the next ordinal, adding the width to that ordinal to give me the next ordinal, adding the width to that to give me the next ordinal until I get to the upper limit, because these numbers ought to be equidistant from each other.
Repeat that last line, sir.
They must be equidistant.
Equidistant.
Fair
You can
enough?
go over about the ordinals for me, please. I'll see if I can catch it.
Do you understand how I calculate the width of the trapezoid?
No.
That's the Vx equal 2 minus the negative 1 over 3. That's the part. Yes, sir. That I think that's
All right. I hear somebody say no. So look at this. The no person, look at this, please.
Okay.
It is going to be B minus A. B is the upper limit minus the lower limit divided by the number of trapezoid.
Yes, sir. I get it.
Okay, you get it now. All right, great. So that's what I did. My upper limit is 2. So the 2 right here, so minus my lower limit. My lower limit is negative 1. Says my upper limit minus my lower limit divided by 3. And 3 is the number of trapezoids. 3 is the number of trapezoids. So 3 divided by 3 is going to be equals to 1. And what happens here is that that 1 tells me that this is the width of my trapezoid. That 1 tells me the width of the trapezoid. So I know how my trapezoids are going to be measured.
Sir?
Yes, sir. Yes, Mikey.
Is that all time we're gonna get the trapezoid?
Yeah, if I use the trapezoidal rule, you're going to get the trapezoid. Yeah, man. Yeah, man. Yeah. Remember, it's you creating the trapezoids, you know. So that's what what it is that we're doing now is creating our trapezoids, because the question asks us to use the trapezoidal rule. Follow me, Mike?
Yes, sir. Following.
So, the n equal 3, what you said is the trapezoid. I think that's what we want to know. If we're going to see this, if we have an exam, will we see n equal 3 or n equal 5 or whatever?
No, the
So
n
that's what-
equal 3, I think that would be like the number of trapezium, sir.
Yes, ma'am.
That's what he's saying. So I'm wondering if we'll get, or it's not going to be so
Well,
straightforward.
I have to tell you the number of trapeziums.
I have, you remember what I said before? I must tell you how many trapezoids, but sometimes I can say to you it has 4 ordinals. Remember what I was saying to you? So this question could have read, use a trapezoidal rule to estimate all of this something here with 4 ordinals. Would it be the same question if I wrote n equal 3?
Yes, sir. It would be the same.
Yes.
It would be the same thing. So that's what I'm talking about. So when you're using the trapezoidal rule, one of 2 things must be given. Either the number of trapezoids, or I can tell you how many ordinals it has.
Okay, so.
Yeah, man.
With the ordinal part.
Say it again?
So I'm begging about to put the ordinal part. Put right trapeziums.
No, but if I give you 10 ordinals, how many trapezoids you have?
9.
9, sir.
9. And if I tell you, and remember, no.
Have to more work to work them out?
No, but in any event, you still have to calculate the ordinals. Because the ordinals is what you're going to substitute into the formula to calculate the stuff. Trust me. And if the question gives you the number of ordinals, when you're calculating v of x, you have to know, then calculate how many trapezoids you have. So however you do the question, you will have to decide on for yourself. It has this number of trapezoids and this number of ordinals. So you have to know the difference between trapezoids and ordinals, which is why I gave you that exercise with your hand earlier. Watch me. So I know I have 4 ordinals: -1, 0, 1, and 2. Look at what I'm going to do. In the function, my f of x, recall my f of x is x squared minus 3. My f of x is equal to x squared minus 3. Look at what I'm doing. Anywhere in the function f of x I see x, I will substitute each of the ordinals. When I'm using the approximation to integration here, in particular trapezoidal rule, I am not actually integrating the function. I'm not adding 1 to the power and dividing by the new power. When I calculate my ordinals, anywhere in the function, the original function, I see x, I'm going to substitute each of those ordinals. So therefore, since I had 3 trapezoids, it must mean that I'm going to have 4 calculations to do. True or false?
True, sir.
So substitute the ordinals into f of x, my original function. Anywhere in the function I see x, I'm substituting each ordinal. So let's go. -1 squared is +1. 1 minus 3 is -2. So my answer there, -2. Put it in blue. Finish that one, move on to the next ordinal, which was 0. 0 squared is 0. 0 minus 3 is -3. See it right here, sir? -3. The next one is 1. 1 squared is 1. 1 minus 3 is -2. Right here, so. The next one is 2. 2 squared equals 4. 4 minus 3 is equals to 1. Right there, so. Any questions?
Yes, sir. Sir, the ordinals, the calculation from the -1 up to 2. How did you get that again? Can you
Yes,
just
the ordinals. Yes, sir. Remember I said I wanted to know. Yes, that one right there. How did you get the ordinals? I asked before. Yes, sir. But how do we get to this point?
Yeah, you understand how I got the v of x, right?
Yes, sir.
Yes, sir.
Yes, sir, we understand that.
Yeah, the upper minus the lower over the top. Over the
Number of trapezoid. Okay. So what I'm doing, I'm starting with the lower limit and I'm adding the width of the trapezoid to the lower limit until I get to the upper limit. So -1, I must start with the lower limit, -1.
Yes.
That's my starting point. What is -1 plus 1?
0.
0.
That's my next ordinal. So I'm adding the new ordinal now to the width of the trapezoid. So 0 plus 1.
1, sir.
1.
And that's how I get the 1, which is the third ordinal. What is 1 plus 1?
2, sir.
That's how I get the next ordinal. Do I move on?
So, sir,
No,
what
sir.
you're basically
No,
saying,
sir.
what you're basically saying that you start with the
Lower limit.
lower limit,
Right. And I must end with the
upper limit, which is 2.
upper limit, which is 2. So if
Yes,
I
sir,
move, if I move on now to 2 plus 1, 3, that don't make no sense because I'm integrating between -1 and 2.
Yes, sir, it's clear now.
Yes, sir.
All right.
I see.
So let me show you something else now that you can double check. I can take any term and subtract the term preceding that term, and I should get the same number. So let us try 2. 2 minus this one is?
2 minus 1.
1.
1. What is 1 minus 0?
-1.
Really?
Sir, I said 1. I said 1.
Joe, you need to go
Sir,
to the
I
foot of the
said
cross.
1.
What is 0 minus 1?
1, sir.
1.
1, so plus
One.
that. Plus
So,
1.
so when you would have written your ordinals, you can just double check. Any term in your ordinals that you select and you subtract the preceding term, you should get the stuff. So, I mean, you can play around with it. All right, let's go. So when I calculate all of these values, -2, -3, -2, and 1, oh, two of them are -2, yeah, and 1, I'm now going to substitute into my function. So the function here again, remember, I have 4 ordinals, 1, 2, 3, 4. And where you see the plus sign is a V of your fingers. So this is one trapezoid with a plus sign. The next trapezoid is the other plus sign. And this trapezoid here is going to be the third trapezoid, the other plus sign. So what I normally do is use the plus signs to tell me how many trapezoids I have. Watch me. Remember, the extreme trapezoids, meaning the one with the lower limit and the one with the upper limit, are the ones that are not going to be multiplied by 2. Why, sir? Because it's touching only one side of a trapezoid. The one that is inside of the middle. Let me go here. Look at A. How many sides A is touching? So 1.
1, sir.
Look at X1. How many side X1? How many trapezoid X1 is separating?
2.
2.
Sir.
How many, Mike, you saying something?
I said 2, sir.
Oh, okay. How many sides X2 is separating or is touching? Same difference.
2.
2.
Good. And how many sides B is touching?
1, sir.
1. So that's why when I look at my formula, you don't see any 2 at the first one, and you don't see no 2 at the last one. You only see 2 in the 2 middle one, because the 2 middle ones are the ones that are touching 2 sides of the trapezoids. Does that make sense?
Understand now.
Okay. So please do not multiply each of the terms by 2. Only the middle one them are going to multiply by 2. The 2 end ones are not being affected by this 2. Why, sir? And that's a possible multiple choice question. Why, sir? Cause to say that them only touching one side of the trapezoid, not 2 sides. Let's go. So the first one, the lower limit and the upper limit, are going right back as they are. But every other term that we have are going to multiply by 2. So look at this one. Look at this one. This -1, sorry. Again, the -1 value is going to be -2. So I'll just write the -2 right back as it is here. Look at this 0, which is the next one. This 0 is touching 2 pieces. So this -3 is going to be multiplied by 2. This one is also touching 2 pieces. So this -2 is going to be multiplied by 2. See it here? But the f of 2, remember 2 is my upper limit, that is only going to be affected by itself, which is just 1. So you may say, sir, where this half comes from? Thanks for asking.
Up there.
Just when I calculate the value of my v of x, which is 1, I am then going to divide that value by 2. So in the formula, I have v of x over 2. I have v of x over 2.
So what you're saying, so the half is not a part of the function.
The half, no, you don't know what this function is, this fraction going to be. This fraction is dependent upon what your v of x works out to be.
Oh.
So you have to work out your v of x, and any value you get for v of x, you divide it by 2. Now, sometimes v of x works out to be a quarter, but a quarter divided by 2 is going to be 1/8. So you may have a 1/8 multiplied by the function. But as we go through other examples, you'll see what I'm talking about. But just remember, this 2 in the denominator is consistent. For all trapezoidal question, it's going to be v of x over this 2. You don't know what v of x is going to be. V of x is simply b minus a over the number of trapezoids n. You can have a fraction, you can have a whole number. You don't know. I cannot tell you what v of x is going to turn out to be. What I can tell you is that v of x is going to be divided by n. V of x is going to be divided by n. All right? So let's go. Let's just see if we can just finish this example, one example, and then we'll call it a day until tomorrow, God's willing. So because my v of x was 1, I now need to put 1 over 2. And I have all of these values that I've previously substituted. So it's going to be -2 plus 2 times -3 now becomes -6. 2 times -2 becomes -4. And my positive one is a standalone. What I would have done is to say -2 minus 6 is -8. -8 minus 11 minus 4 is -12. -12 plus 1 is -11. And -11 times a half is going to be -5, sorry. -5.5 or -11 over 2. So that is going to be my calculation using the trapezoidal approximation. I'm going to stop here and entertain your questions for the remainder of the class.
Yes, sir. All right. So you said the 1 over 2 with the half. All right. So the 1 you say is the v of x. That's the 1.
Yes, sir. Yes, sir.
2.
The 2 is always there. The 2 is constant in the formula. The 2 is always in the formula.
Oh, okay. Oh, it's that 2.
So yes, let me jot that down.
So any value at all you get for v of x, just divide it by 2. The 2 not going to change. Let me be careful of let me be careful of what I say right here when I say not going to change. The 2 is constant in the formula. So when you look at a trapezoidal formula, you're going to see the change of x over 2. But when you evaluate the function, that fraction may not be 1/2. That fraction could be 1/8, 1/16. It all depends on what the value of v of x is. In this question, my fraction that I'm multiplying by became 1/2 because v of x was 1.
So like what did -1? -2,
No, no. Because the -1 is already subsumed into 2 minus -1.
Okay.
Yeah, man. So that negative value not have nothing to do with it. Any other questions? Please ask them now.
Yes, sir. Suppose like how the formula layout there with the +1 at the end. Suppose I write no, sir, go back up. Where you just were. Yeah, right here. And you open the bracket, -2. Suppose me plus the 1 at the end. And then 2 times the rest of values.
You wait it wrong.
I lay it out that way. That's what I'm asking.
No, you can lay it out like that, you know. Okay. You see the first line that the first one that I lay out.
Yes, sir.
Just remember, just be consistent. The first term, which corresponds to the lower limit, and the last term, which corresponds to the upper limit, are not going to be multiplied by 2.
Yes,
look
sir.
back at the
No.
Yeah, man.
If I add the last value and the first value before multiplying the rest of values by 2, if I lay it out that way, it's
yes. So what you can do, but you see, so your answer is yes. So I can write down the first value, and I can write down the last value, and then we can add up all of the other value them and multiply by 2.
Yeah.
But yes, you can. Mathematically, it will be correct. But to be honest with you, we prefer if you do it that way, yeah. So you can see that the 2 are only multiplied, that you pick up the first term and the last term. So what she's asking is, sir, could I have added -2 to +1 and then now add up the other 2 numbers and then just multiply by 2? Yes, you can. But when you mix up something, so you may get mixed up yourself and run the risk of losing a couple of marks out of a very easy topic that carry sometimes 7, 8, 9, 10 marks. I don't want to do that. So I'm going to be encouraging you all to lay it out just like what I have it laid out. So when you look at it, you can be rest assured that the first term and the last term are the only two terms that are not affected by this scalar quantity of 2. Then, sir, is always 2, you're going to multiply the inner ones then by, then on the 2 sides. The trapezoid are going to touch. It can't be any other number but 2. I explained to you why it's 2. Because each trapezoid, each ordinal, sorry, is touching 2 trapezoids. All right? Any other question?
So my question and the same thing there. I am still lingering. The original, the ordinals, let me get it, the ordinals. Right up there, because I am still, yes, right there. I know that you start with the lower limit. But then I say it's the lower limit, what's it, minus 1?
I'm adding the lower limit to the width of the trapezoid.
To the width, that is
Yes,
the one
miss.
at the top.
Yes, miss.
Oh, I didn't get that. Let me write it down.
So I'm adding the lower limit. That's how we're going to start off. So it's going to be the lower limit. So I write the lower limit first, in order, because the lower limit is when, if you look at the question, you recognize that the lower limit and the upper limit give are part of the ordinals. Talk truth.
Yes, sir.
Yes, sir.
So we're going to start with the lower limit. So it's the lower limit plus the width of the trapezoid to give it the second ordinal. And then the second ordinal plus the width of the trapezoid to give it a third ordinal. And then the third ordinal plus the width of the trapezoid to give it a fourth ordinal. And by the time we reach the fourth ordinal in this particular question, you will see that it corresponds to the upper limit. Yeah.
Okay.
Joe was asking a question earlier. Joe was asking a question earlier. Then, sir, if you increase the number of trapezoids, and I will for calculation, because if I had more trapezoids than this, the width couldn't be 1. The width is going to be less than 1. So I'm going to break up the trapezoids into smaller pieces. So I'm going to have multiple pieces on the inside. And that's one of the other reasons, Alison, that I don't want you to add up the middle terms and then multiply it by 2, because you may get mixed up with that. Write it out so that I can see it, because if the question is wrong, but I can follow your methodology and find out where you went wrong, then I can award the points up to that point. So you can get the question wrong, answer real wrong, but you still can pick up a 7 out of 10 because you make the mistake on the last part of the question. Your ordinals are correct. Your V of X is correct. Your substitutions are correct. Substituting to the formula is correct, but it's when you evaluate in the formula now is where you make the mistake and you're going to lose a 2 or a 3 marks. So you can pick up a 7 out of 10 or maybe a 4 out of 7 or whatever the situation is. So your methodology is going to be very important in order to first complete the stuff. Any other question?
Sir, so it's safe to assume that you're going to always give the question like this.
Yeah, man. Except that in this question, I told you that n is equal to 3. I gave it the number of trapezoids. Don't.
Yes, sir.
All right. I can give you a question.
X minus 1 and what?
All right.
That's what I meant, sir. So see that question and I look the same.
No, worry about that question yet, man. No worry about that question yet. All right, worry about this now. You see example 2 for me? What it says?
Ordinals.
And what 6 ordinals work out to be in terms of trapezoids?
7.
So
5. That would be 5.
It's going to have 5 trapezoids.
So we're going to have 5.
Sorry.
1 down, 5.
Right, we're going to have 5 trapezoids. All right, so don't worry about it. The one here, this is one of the easiest questions on the paper. A May 2019 past paper is one of the easiest ones. We will do this tomorrow, God's willing. Don't worry about this. This question is even easier than the example that I showed you.
Man.
Trust me, real talk.
So sorry,
Real talk.
with this?
Real talk. This is easier than the example that I just showed you. And if you understand the example I just showed you, you're good to go. The point is,
the 4 is the.
say the 4 is the what?
The 4 is the top one. What you
Very
call
good.
it, sir?
Upper limit.
The upper limit.
And the one is the?
Bottom.
Oh, lower limit.
Lower limit.
Oh, I Chanel. Yeah, look.
Ali,
Oh.
no, no, this one is mine. Let me take it. Ali.
Yes, sir.
You see when they come class, what happened?
Sir,
No,
explain
no, say nothing
why
to
a
me.
Wednesday classes alone must delay.
Listen, no say nothing to me. Because look how you turn up a while ago. You shine like a diamond a while ago.
Diamonds, yeah. Shine like a diamond.
That's very good, Chanel.
I had no clue what that was.
I'm need to ask you if it's safe to assume that question them are gonna look the same.
And I'm saying to you, but you just, I doubt if you didn't even read the question. But you just assume that the 4 is going to be the upper limit and the 1 is the lower limit. Very good. This is even easier. And them here the function.
A, I don't at the bottom and B at the top.
Same way, so.
The first one would be A and the second one would be the B and the B, they are top and the A.
Same way, so. Good to go. And right here, it's right there and then. Anything with them key in the function thereafter. So it says the SketchUp represents whatever that is. All of what you're looking at right there, so with the x squared plus 2, and you have the upper limit and the lower limit, if you never read any more part of this question, and you follow what I did up top, you will still end up getting the same answer. The question is just wordy, because I'm giving you a real life question, just wordy. But you can do the question. All right. Bless up your good self.
So, sir, what did it ask for? It didn't ask for anything.
Yeah, it just asks us to calculate the length of the perpendicular offset of equal intervals. See, it's just telling that it's equidistant. When them something here, does it tell us it's equidistant from the straight line of the curve to the boundary of the dot, and then it says the field manager of the company would like to know the area of the plot of land before using it. Remember, when I was teaching you calculus when I said to you that Smarty father build them one piece of land on an Ochi, and them never recognize the prime land space, but when it is that them integrate and get the area under the curve, them recognize so them can get one big hotel out of it. Yeah, this is exactly what the question is saying now. The field manager of the company would like to know the area of the plot of land before using it. So we need to calculate the area of the plot of land using the trapezoidal rule. So when these quantity surveyors come and want to find out, to maximize, when them buy a piece of land out of any old house, them buy the land and I see them put up an apartment, that's exactly what they do. They calculate the area under the curve, and they will have to do a geological survey to ensure that they are not going, they are staying several feet above the water table. Because if they build on the water table and any earthquake come, the house going crumble, right? So that's why the geological survey comes into play, so they know that, okay, fine, I cannot go beneath XYZ. And finally, before we go, I want you to look at, well, for those of you who drive on Ligonier Avenue, there is an apartment. Let me tell you, the apartment I think is right beside. It is across from one of the gates, the Sovereign Gates on Ligonier Avenue, and it could be the last apartment before you head on to Hope Road. Now, when you look at the stuff, you will see when the gate is open, you will literally see the car park right there, so because they couldn't put the car park underground, like some built, like the NHT houses that did flood out in the heavy rains last year.
Yes, sir.
Good. The car park is beneath the surface, beneath the surface of the earth. It's underground. So which is why the drainage wasn't good. And because it's on an incline, when the rain came, the water just flooded out the place. So the drainage was poor. But in this particular house development, the houses are built, the apartment are on columns. Because clearly there was something with the groundwater that they couldn't go further down. They would have come across something, which is why they had to put the apartment that way. If I do pass there and I get a glimpse on the inside, I'll take a pic and I will show you what it is I'm talking about. This is all in the whole business of construction and calculating the areas under the curve, right? And they give you something about direct integration gives 27, find the percentage error. So we can calculate the percentage error. Is so much marks for this question? 20 marks. 20 marks. Already, if you followed what it is that I did in class tonight, you should be able to pick up all these 20 marks. Because you don't have to actually do part 2, you don't have to actually do the integration in part 2 because they told you what the direct integration gives. It says if the direct integration gives the exact value of 27 square units, find the percentage error. All you have to do is find a percentage error. If you have the actual and you have the estimated, you put the estimated over the actual times 100% and you get a percentage error. Boom, done, 20 marks. Anyhow, all things being equal, we should see each other tomorrow. We'll talk. Have a good one.
Okay, sir.
Come on, take care.